The bell housing is a rather awkward shape to get a good camera angle on, but it was really easy to bolt down because we've got the big four studs that come through. So I've just got the hold downs through those and down into T-nuts. Used the coaxial indicator to indicate in on this hole that is where the input shaft and its surrounding tube come through. And you know, these are only good for a few thou, but they're nice and fast, and it's got a decent reach to get down in here. The clutch slave cylinder has a 72mm PCD, 3-bolt pattern, and what I should be doing is coming in here with a slot drill, a 2-flute end mill, just to create a flat spot, and I'll note the height difference between this one up here, which is on a flat area. These two are on a little bit of a shallow slope, so these will be deep enough to get a full circle, and then I'll note the depth compared to this one. They will be drilled and tapped for M6, and then I'll make some tap spacers, and initially I'll just be using some cap head screws from the slave cylinder side for testing, but ultimately what I'll probably do is to use studding through from the back and Loctite it in, and then I can use nuts to retain the slave cylinder. But I'm just getting set up to make the flat spots, drill and tap. I may even use just stacks of washers to do the initial testing, see what the clutch action is like, whether it's enough of an improvement to be worth doing. Hopefully it is. There are other advantages like not having to adjust the clutch, and yes, concentric slave cylinders are a pain when they fail, but they do have reasonably long lives on them, and a new cylinder will be going in, so I don't see it as a particular problem. It's not the hardest thing to get the transmission out of. I've done far worse. So I just used the table in the Zeus book to get the positions, and I've got my 3 flat spots in there. So the next thing to do will be to drill and tap them the M6. I've got the bell housing all mounted up, and you can see inside we have the slave cylinder mounted up, and although it's a little difficult to see, I get the lighting in the right position. There is a decent amount of distance between that release bearing and the clutch fingers, so maybe 10, perhaps even 15mm. So there's plenty of room in there to put an extension on the end of the release bearing with a radius to operate the flat fingers. And in fact this is as far out, or is in fact further out than the cylinder should ever extend. It's against its extension stop, and the pedal needs to be set up so that the pedal bottoms out or simply runs out of travel before the cylinder ever extends this far, because if you extend it beyond this point you damage it. But I'm pretty happy with how that's looking, and with a little bit more work we'll be able to rig it up and test it again. Well, this little pile of chaos is my first testing of the new clutch concentric slave cylinder setup. So I've got it bolted in just with stacks of washers, They're not quite the right thickness, but it's within 0.2mm of them being right, so I'm not too worried about it. I've got the pressure plate on the flywheel with no clutch disc in it, which means that the fingers are further outwards than they will ever be, even with a worn clutch plate. And this setup was just so that with this installed, have I got some cylinder travel remaining? And yes, I have. That gives me some reference dimensions, as it were. What I've got here is the original inner fitted backwards to one of the flat face adapters, and that is simply fitted onto the slave cylinder with some dabs of super glue so that I can it'll hold in place and I can knock it free later. And from a comment that somebody else made, I did some research to discover that in another application they're doing a similar thing of putting a radius adapter on a flat nose release bearing and using Loctite, which is another anaerobic adhesive. So that's a valid solution. I'll have to make something that comes around and centres on either the ID or the OD. The ID's not got a lot of clearance in there, but that's probably something similar. I may pack this cylinder out on longer spacers and use a shortened adapter on the front, but we'll see. Well, at least we've got some base dimensions to work on. So now I've determined the cylinder isn't bottoming out, I shall set this all up again with the clutch disc in place and look at hooking up some hydraulic lines, temporary lines again, and doing a test to see if this improves the clutch pedal pressure and whether that will get me to where I want to be without having to use a servo on it. So this is actually take 2 of testing the Concentric slave cylinder because I made a big mistake, and that was that I forgot to put a spacer in behind the slave cylinder, and I had it all hooked up like this. This is my little T-piece arrangement for bleeding it, which was not difficult at all. One of my tricks, when everything is clean and I'm going to be flushing it later anyway, is to run a piece of tubing all the way back to the master cylinder, submerging the master cylinder, and just a circular bleed. But in fact getting the air out of the slave was not a problem. But I forgot to put a spacer behind the clutch slave, and the first time I put significant pressure on it, I blew the back out of the cylinder. And that was yesterday afternoon, and after I'd cleaned up the large fluid spill and pulled everything apart, I quit for the day, so I thought. And then actually I came out here in the evening, put the cylinder back together, made a spacer that correctly supported it, machined one, not the temporary one I had intended to put in and just forgot about, and hooked everything up, bled it in again, and tried the pedal. And it is not just better, it is a lot better. It now has a lovely feeling clutch pedal, nice and light, no free play. You can feel what's going on with the clutch, and I think it's even reduced the stroke necessary for getting it to release. That's a little tricky because all I could do was wedge the clutch pedal down against the bulkhead and then jump out and try turning the shaft, but with the pedal probably an inch from the bulkhead, maybe a little more. The input shaft was spinning very freely, with no drag on the disc. So I think we can actually call this a resounding success. And I have a replacement cylinder on order because I'm not going to trust this one. We do actually have more fluid leaks. I've got paper towel under there, and this is leaking up here somewhere, not quite sure where. It's entirely possible it's this union, because just for testing, that's a 3/8 inch UNF union, and this is a metric T-piece, because the fittings on the slave are metric. And this is something to watch out for. This is a very dangerous situation if it was on a braking system. A 3/8 inch union will screw into an M10/1 thread and fit really pretty well, but it's loose. It's not got enough engagement on the threads, and under significant pressure could just blow. For testing, and this is a clutch system, so the line pressures are quite low anyway, that's fine. And you know, this is a lash up just to get the testing done. And so now I will be moving on to machining the other bell housing, a lovely clean one sitting over here. I shall do the modifications again and mount up the new cylinder when it arrives. I've now done the machining on the bell housing I'm going to use, and this is basically just getting this area flat and then two more points, and with a known distance between them, see I've noted on the bell housing, and I then machined some spaces that fit in. These are also threaded. There's not a lot of thread depth in the alloy there. Now this is under compression with the cylinder, so there's not a lot of strength requirement. My only worry is the studs actually coming out. I'm using studs rather than bolts because this is obviously got oil on the other side and needs to seal up. So what I have done is I have made a sheet metal disc, and when the studs are trimmed to length and fitted, I will then just TIG weld a couple of spot welds on each just to stop them rotating. You can see I've got the original cylinder, the one I blew the back out of. The replacement has arrived and has the dust boot on this one, which is nice. So yeah, using these flanged nylock nuts, which I rather like, saves messing around with separate washers and so on. Spacer plate underneath, and these are used nylocks, still got plenty of holding friction, but are lower torque to install than fresh ones. And yeah, this is working quite nicely as an arrangement. I did consider a different setup that wouldn't require machining the bell housing, because I had a couple of people interested in the conversion, but although it's feasible, it's got some other issues that I didn't want to spend time sorting out when I already knew that I had a solution which was no problem for me because the bell housing was off. The other thing I've done is I've gone in there with a carbide burr and then with a flat wheel just to blend things afterwards, and created the clearance for the starter motor. And hopefully you'll agree It's a rather neater job than the previous bell housing had, and in fact, should this gearbox go back at any stage to being on the end of a Lotus engine, no repairs will be necessary. Although I've cut into the edge of the dowel location will still be functional. We haven't broken through, and I think the concentric slave is an upgrade worth doing anyway, so there would be no reason necessary to convert that back, and if necessary the studs sticking out could just be cut off flush so that the original setup would work. I used the Sharpie Magnum just to glue up the starter motor so that I could see contact points and get the clearance all sorted out. So I'm really pretty pleased with that as a job, and now I just have to wait for things like a longer input shaft to arrive and for me to go through the shimming process. So this is the bell housing I'm going to end up using, pretty much all finalised. We've got the plate on the back welded to these studs. The spacers are installed. These are threaded down, nipped up. I've used wicking grade Loctite to both keep it retained and also hopefully to seal the studs up against oil leakage. I may well just use a little bit of 3-bond silicon sealant when the adapter plate goes on, which I don't think I've shown before. Just got a recess in the front to suit this spigot on the back of the bearing. This face, which is the rear of the cylinder that I blew out on the other one, is at the same level as the clamping face, and that's just got a little bit of a relief cut in it, and it's quite a snug fit. It drops down on there, cylinder on top, and then one final job will be to machine an adapter to mount the radius adapter on there.